Building codes, particularly the International Residential Code, often necessitate the utilization of airtight electrical boxes when installing electrical components in unheated spaces, such as attics. This requirement stems from the unique environmental challenges presented by these spaces. Unheated attics are subject to significant temperature variations and are prone to moisture condensation. The primary reason for mandating airtight electrical boxes is to mitigate the potential risks associated with air and moisture infiltration. Conversely, non-airtight electrical boxes can act as conduits for moisture to enter the electrical system. This moisture can lead to electrical shorts, which pose a fire hazard. Furthermore, the presence of moisture can accelerate the corrosion of electrical components, reducing their lifespan and compromising their reliability. Secondly, air leakage through non-airtight boxes can diminish the effectiveness of insulation. This is because air movement within the insulation layer can disrupt its ability to maintain a consistent temperature gradient, leading to heat loss in the winter and heat gain in the summer. Thirdly, moisture infiltration can foster the growth of mold and mildew. These biological contaminants can not only damage building materials, but also pose health risks to occupants. Several types of airtight electrical boxes are available to meet these requirements. One type is gasketed boxes. These boxes feature a rubber or silicone gasket around their perimeter, which creates a tight seal against the surrounding air. The gasket effectively prevents air and moisture from entering the box through any gaps or cracks. Another type is boxes with built-in gaskets. These boxes have gaskets that are integrated directly into their design, ensuring a consistent and reliable seal. The built-in gasket eliminates the need for separate gasket installation, simplifying the installation process. A third type is sealed boxes. These boxes are constructed from moisture-resistant materials and are sealed at all openings. The sealed construction provides an additional layer of protection against moisture intrusion. It is important to note that there may be exceptions to these requirements in certain circumstances. For example, heated attics may not be subject to the same airtightness requirements as unheated attics. In addition, local building codes may have specific requirements or exceptions that apply to particular situations. To ensure compliance with all applicable building codes, it is always advisable to consult with the local building code official. The building code official can provide clarification on the specific requirements that apply to a given project and can answer any questions about the proper installation of electrical components in unheated spaces. By following these guidelines, it is possible to ensure the safe and effective installation of electrical components in unheated attics, while also protecting the building from moisture damage and other potential problems. The NEC, or National Electrical Code, addresses general requirements for electrical installations, but the requirement for airtight boxes in unheated spaces typically falls under the jurisdiction of local building codes, often based on the International Residential Code. The NEC focuses more on the electrical safety aspects, such as proper wiring methods, overcurrent protection, and grounding, while building codes emphasize energy conservation and preventing moisture-related issues. The inspector is correct in pointing out that the issue relates more to building code compliance than direct NEC violations. Using A/C, or insulation contact, rated recessed lighting fixtures in an attic space isn't necessarily an NEC violation if the wiring and installation comply with NEC requirements. However, the building code adds the requirement of airtightness to prevent air leakage and moisture intrusion. Therefore, the failure during the rough inspection stems from not meeting the building code's airtightness requirement for electrical boxes in an unconditioned attic. To rectify the situation, one approach is to replace the existing A/C cans with airtight versions specifically designed for this purpose. These airtight fixtures often have gaskets or seals to minimize air leakage. Another approach is to seal the existing A/C cans to make them airtight. This can involve using caulk or expanding foam to seal any gaps or openings around the fixture. The specific method will depend on the fixture design and the recommendations of the manufacturer. Regardless of the approach taken, it's essential to ensure that the modified or replaced fixtures still comply with all applicable electrical codes and safety standards. It's also crucial to verify that the sealing method doesn't impede the fixture's ability to dissipate heat, as overheating can pose a fire hazard. In addition to addressing the airtightness of the recessed lighting fixtures, it's also essential to examine other potential sources of air leakage in the attic, such as gaps around wiring penetrations, plumbing stacks, and attic access panels. Sealing these gaps can further improve the energy efficiency of the building and prevent moisture problems. Remember that local building codes may have specific requirements for sealing these penetrations. When selecting airtight electrical boxes, consider the following factors. Firstly, the box's material. Boxes made of durable, moisture-resistant materials, such as plastic or metal with a corrosion-resistant coating, are better suited for attic environments. Secondly, the box's design. Look for boxes with features like pre-installed gaskets, sealed seams, and cable clamps that provide a tight seal around wires. Thirdly, the box's size. Choose a box that is large enough to accommodate the wiring and devices being installed, while also leaving enough room for proper heat dissipation. Fourthly, the box's listing. Ensure that the box is listed by a recognized testing laboratory such as Underwriters Laboratories to ensure that it meets applicable safety standards. Before proceeding with any electrical work, it is advisable to consult with a qualified electrician or building inspector. They can provide guidance on the specific requirements that apply to the project and can ensure that the work is performed safely and in accordance with all applicable codes. In summary, the requirement for airtight electrical boxes in unheated attics is a building code requirement aimed at preventing air leakage, moisture intrusion, and related problems. By using airtight boxes and sealing other potential sources of air leakage, it is possible to improve the energy efficiency of the building, protect electrical components from corrosion, and prevent mold growth. Always consult with local building officials and qualified professionals to ensure compliance with all applicable codes and safety standards. Airtight electrical boxes are designed to minimize air leakage. Air leakage in buildings can lead to several problems, including increased energy consumption, reduced comfort, and moisture condensation. Airtight boxes help to reduce these problems by preventing air from flowing freely through electrical outlets and switches. This can be especially important in unheated attics, where temperature differences between the inside and outside of the building can be significant. Using airtight electrical boxes can help to reduce energy consumption by preventing heat loss in the winter and heat gain in the summer. This can lead to lower utility bills and a more comfortable living environment. Airtight electrical boxes can also help to reduce moisture condensation in walls and ceilings. Moisture condensation can lead to mold growth, which can cause health problems. By preventing air from flowing freely through electrical outlets and switches, airtight electrical boxes can help to keep walls and ceilings dry and prevent mold growth. There are several different types of airtight electrical boxes available. Some boxes are designed to be used with standard electrical outlets and switches, while others are designed to be used with low voltage wiring. It is important to choose the right type of box for the application. When installing airtight electrical boxes, it is important to follow the manufacturer's instructions carefully. This will help to ensure that the boxes are installed correctly and that they will provide the desired level of airtightness. In addition to using airtight electrical boxes, it is also important to seal any other openings in walls and ceilings. This includes gaps around windows, doors, and pipes. Sealing these openings can help to further reduce air leakage and improve energy efficiency. If there are concerns about air leakage, it may be beneficial to have a professional energy audit performed. An energy audit can help to identify areas where air leakage is occurring and can recommend solutions to reduce air leakage. Addressing air leakage in a home is a crucial step toward improving energy efficiency, enhancing comfort, and preventing moisture-related problems. Airtight electrical boxes are a valuable component in achieving these goals, particularly in areas like unheated attics that are susceptible to temperature fluctuations and moisture condensation. When considering airtight electrical boxes, it is important to select products that meet relevant industry standards and are compatible with the specific wiring and electrical devices being used. Professional installation is recommended to ensure that the boxes are properly sealed and that all electrical connections are made safely. Building codes are sets of regulations that govern the design, construction, and alteration of buildings. These codes are developed and enforced by local, state, or national governments to ensure the safety and welfare of building occupants. Building codes address a wide range of aspects, including structural integrity, fire safety, accessibility, energy efficiency, and plumbing and electrical systems. The specific requirements of building codes can vary depending on the location and type of building. However, the overall goal is to provide a minimum standard of safety and performance for all buildings. Building codes are often based on model codes developed by organizations such as the International Code Council, or ICE, and the National Fire Protection Association, or NFPA. These model codes are updated regularly to reflect the latest advances in building technology and safety practices. Local jurisdictions can adopt these model codes as is or modify them to meet their specific needs. Building codes are enforced through a system of permits and inspections. Before beginning any construction project, a building permit must be obtained from the local building department. The permit application typically includes detailed plans and specifications for the project. Building inspectors review the plans to ensure that they comply with the building code. During the construction process, building inspectors make periodic visits to the site to inspect the work. If any violations of the building code are found, the inspector can issue a stop work order until the violations are corrected. Once the project is completed, a final inspection is conducted to ensure that all work complies with the building code. If the project passes the final inspection, a certificate of occupancy is issued, allowing the building to be occupied. Building codes play a critical role in ensuring the safety and quality of buildings. By setting minimum standards for construction, building codes help to protect building occupants from hazards such as structural collapse, fire, and electrical shock. Building codes also promote energy efficiency and accessibility, making buildings more comfortable and usable for everyone. If there are any questions or concerns about building codes, it is always best to consult with a local building department. Building officials can provide guidance on the specific requirements that apply to a given project and can answer any questions about the proper construction of buildings. Building codes also address energy conservation. This often includes requirements for insulation levels, window efficiency, and air sealing. The airtightness requirement for electrical boxes in unheated attics falls under this category, as it aims to reduce air leakage and improve the overall energy efficiency of the building. The International Residential Code, or IRC, is a widely adopted model building code that provides comprehensive regulations for 1- and 2-family dwellings and townhouses. It covers various aspects of construction, including structural, fire safety, plumbing, electrical, and mechanical systems. The IRC is updated every 3 years by the International Code Council, or ICE. Local jurisdictions can adopt the IRC as is or modify it to meet their specific needs. The IRC is a valuable resource for builders, contractors, and homeowners who want to ensure that their homes are safe, durable, and energy efficient. The IRC is organized into chapters that cover specific topics. For example, Chapter 3 covers building planning, Chapter 5 covers floors, Chapter 6 covers walls, and Chapter 7 covers roof ceiling construction. Each chapter contains detailed requirements for the design and construction of these building elements. The IRC also includes appendices that provide additional guidance on specific topics. For example, Appendix E provides information on manufactured housing, and Appendix H provides information on patio covers. The IRC is a complex document, but it is essential for anyone involved in the construction of residential buildings. By following the requirements of the IRC, it is possible to build homes that are safe, durable, and energy efficient. If there are any questions or concerns about the IRC, it is always best to consult with the local building department or a qualified construction professional. To find the specific requirements in the IRC related to air sealing and insulation in attics, look at sections that cover building thermal envelope requirements. These sections detail the required insulation levels for attics, walls, and floors, as well as requirements for air sealing to prevent air leakage. In the IRC, the specific section that addresses air sealing of the building thermal envelope is typically found in Chapter 11, which covers energy efficiency. Within Chapter 11, look for sections that discuss air leakage and insulation. These sections will outline the requirements for sealing penetrations and joints in the building envelope, including those related to electrical boxes. Specific requirements may be found in sections like 1102.4, which deals with air leakage, or similar sections depending on the specific edition of the IRC being used. These sections will specify the maximum allowable air leakage rates and provide guidance on how to seal penetrations and joints to meet these requirements. Referencing the specific edition of the IRC adopted by your local jurisdiction is essential, as code requirements can vary from one edition to another. Additionally, your local building department can provide clarification on the specific requirements that apply to your project. Air sealing is a critical component of energy-efficient construction. It involves sealing all cracks, gaps, and penetrations in the building envelope to prevent air leakage. Air leakage can account for a significant portion of a building's energy loss, making air sealing an essential step in reducing energy consumption and improving comfort. Air sealing not only saves energy but also improves indoor air quality by reducing the infiltration of pollutants and allergens. It also helps to prevent moisture problems by reducing the amount of moisture-laden air that can enter the building envelope and condense on cold surfaces. There are many different methods for air sealing, including caulking, weather stripping, and using spray foam insulation. The best method will depend on the specific location and type of air leak. It is important to carefully inspect the building envelope to identify all potential air leaks and then select the appropriate sealing method for each leak. Air sealing is an ongoing process. As buildings age, they can develop new air leaks due to settling, cracking, and other factors. It is important to periodically inspect the building envelope and reseal any leaks that are found. Properly air sealing a building can significantly reduce energy consumption, improve indoor air quality, and prevent moisture problems. It is an investment that will pay for itself over time in reduced energy bills and improved building performance. The building thermal envelope refers to the components of a building that separate the interior conditioned space from the exterior environment. These components typically include walls, roofs, floors, windows, and doors. The thermal envelope plays a critical role in regulating the temperature and humidity levels within the building. A well-designed and constructed thermal envelope can significantly reduce energy consumption and improve occupant comfort. To ensure proper thermal performance, the building envelope must be adequately insulated and air-sealed. Insulation helps to reduce heat transfer through the envelope, while air sealing helps to prevent air leakage. Air leakage can account for a significant portion of a building's energy loss, making air sealing an essential step in improving thermal performance. The thermal performance of a building envelope is affected by several factors, including the type and amount of insulation, the air sealing methods used, and the climate in which the building is located. In colder climates, a high level of insulation is typically required to maintain comfortable indoor temperatures. In warmer climates, shading and ventilation strategies may be used to reduce heat gain. Proper design and construction of the building thermal envelope is essential for creating energy-efficient and comfortable buildings. It is an investment that will pay for itself over time in reduced energy bills and improved building performance. The airtightness of electrical boxes in unheated attics is just one aspect of ensuring a well-sealed building thermal envelope.